person. So just be prepared to show up, be prepared for me to ask you a question. But it'll be a quiz grade, and we're going to go through it in class, so that should help a little. But still, having 2 other quiz grades, we're going to need to make those up. But for today, I just wanted to review areas of some other shapes. So yesterday we went over the area and perimeter of a triangle. And then you guys should know the area of a square or a rectangle, right? A square side times side, which is really base times height. Rectangle is base times height. You know, nothing crazy. Parallelogram, just like a slanted rectangle, it's still base, and then height again. Height of a parallelogram is just like a triangle, right? This would be the height, the vertical distance that makes a right angle with the base, right? Not one of these sides, but that would be the height. Okay, and then a trapezoid, same thing. When I see base 1 and base 2, that means the non-slanted sides. It doesn't matter which one is which. And then again, the height is the vertical line that makes a right angle with one of the bases, not one of these. These would be the heights. Okay, and then lastly, this is the one that I think maybe we need to revisit the most. We should have seen this at some point, but it's okay if we don't really remember. So these are all areas, but I also included circumference here. But the area of a circle is pi times the radius squared. Remember, pi is just a number. You can find pi in your calculator, or pi should just be 3.14. You could just use 3.14 if you want to be super accurate, 3.1415. And it goes on forever, right? Or there's a pi button probably on your calculator somewhere. I know there is on your TI-84 app if you have that on your Chromebook, which you should. And then R is the radius. Remember, the radius is half of the distance to the center of the circle, right? And then also the diameter. The diameter is the distance across the entire circle through the center, right? And the distance is then obviously going to be 2 times the radius, right? The radius is half the distance, or from the center to the edge, but a diameter is all the way through, right? Because this would be another radius this way, right? That's going to be, the diameter is going to be 2 times the radius. So the area is just pi, which is just a number, and then r, which is your radius, squared. That's it, right? They end up just being numbers. Now your circumference is all the way around the circle, aka the perimeter of the circle, right? And that's going to be equal to 2 times pi times r. But we said 2 times r, 2r was the same thing as the diameter, right? So you could just do pi times the diameter as well. And if you're uncomfortable with the circle, I would definitely make sure this is written down at some point somewhere. The rest, it's a little less important, maybe the trapezoid, but the others you should kind of know. And I have a PDF of this on a previous assignment when we first did this, and I'm actually going to make a note right now for me to go back and post it. So you guys can print that PDF or copy it down then. But we are going to move on to some examples. And actually, before we do, let me go grab my calculator real quick. All right. So here we have find the area and perimeter of the figure. Well, we said the area of a circle is pi r squared, right? And so A equals pi times the radius 12 squared. And again, pi, you can just write 3.14, right? And that's just something you put in your calculator, 3.14 times 12 squared, which is 452.16. And then I and Delta Math will usually ask you to round to the nearest tenth. And so that would be 52.2. We're going to round up because that 6 is 5 or higher. And then we could say units squared. Now, if we were to do the perimeter, that's the circumference, right? The circumference or the perimeter, if you want to write C or P, whatever works, was either pi times diameter or 2 times pi times r. And that's, again, just from this sheet here, 2 pi r or pi times diameter. So we have the circumference, which is the same as the perimeter, is 2 times pi, which we said is, we could just type in as 3.14, times r, the radius is 12. And again, this is something we can just throw in our calculator. 2 times 3.14 times 12, 75.36. Right? And then again, usually if we're rounding to the nearest tenth, we could say that the perimeter is 75.4. We're going to round up again. And then this would just be in units, whatever the units happen to be, right? It could be feet, could be inches, could be meters, anything you need it to be. Okay. So a little bit of review on circles. We're going to do a couple more involving circles after this. That's your basic one, if you're given the radius. Okay. Now, for this one, we need to find the area and perimeter, but we are given the diameter, the whole length is 4, but right, the area is pi r squared. Right, we know pi is 3.14, but then we have to be careful. The radius is half of the diameter, which is going to be 2, right? Half of 4 is 2. If the whole length is 4, then the radius, half of it, is going to be 2. So we have 3.14 times 2 squared, which you can just type in your calculator, 12.56. Then again, if we're rounding to the nearest tenth, that 5 is going to round up to a 6. And whatever units we might have are going to be units squared. If it was feet, it would be squared feet, inches, squared meters, whatever it is. And now for the perimeter, or the circumference of a circle, it's the same thing. We could do 2 pi r, or remember we could do pi times diameter. So I'm going to do pi times diameter. Pi is 3.14 times diameter. It gave us was 4. And you should notice something special about this circle, because the circumference is also 12.56 or 12.6 units. And that's just a coincidence. And it has to do with that 2 squared is 4, right? And also 2 times 2, that happens to be 2 squared, which is 4, right? So these happen to be the same. But you still want to follow these formulas. Okay. This is supposed to be a semicircle. I know it probably maybe looks a little stretched, but we're just going to leave it. So if this is half a circle and it wants the area and perimeter, again, area is pi r squared, which is going to be 3.14 times 7 squared. But there's a kick here, right? So this would be for a full circle. So 3.14 times 7 squared. $153.86. This would be for an entire circle with radius 7, but we have a semicircle. We only have half a circle. So if we only have half a circle, what we need to do at the end of this is divide it by 2. And so the real area we get, I'll maybe do AC for A of an entire circle, and then AS for the area of a semicircle. We just have to get what we get, or divide by 2, and we get 76.93. And then if I'm rounding to the nearest tenth, that's 76.9, round down. Then whatever the units are squared. Similarly for the perimeter, the perimeter, aka the circumference, was 2 pi r, right? And now maybe if we want to get ahead of the curve, right, we're only going to have perimeter of half of a circle. This is the perimeter for an entire circle, but we want of just half the circle, so we should divide it all by 2, and that 2 and that 2 are going to cancel, and we're going to be left with pi times r, which is 3.14 times 7. 21.98. And then if we're rounding to the nearest tenth, this 8 is going to bump this 9 up to another 1, so C equals 22. And then to signify that I did round to the nearest tenth, I'm going to do 0.0. All right. We have time for the last one. I think we do. So that's just the circle. Again, pi r squared for the area, 2 pi r, or pi times diameter for circumference. Once you just use it enough, you get used to it. There isn't going to be homework for this one necessarily, so just make sure we're comfortable with this. But yeah, that's all it is for the circles. And if it's a semicircle, you just have to take your area for a circle or the perimeter for a circle, the circumference, and just divide it by 2, right? Because you have half the circle. So last one, maybe we could look at a trapezoid here. Find the area and perimeter. Well, the area was 1/2 base 1 plus base 2 times h. Well, we're missing the bottom base here, and we have a height h, but we're going to need to find these sides as well to do the perimeter. So let's just work on finding everything. And there's something I see here. I can draw, right? It might be helpful for me to draw a line in here. Let me. I'll get a dotted line. It'll be helpful for me to draw a dotted line in here, over here, because now we can see another triangle, right? And now we can start labeling some more stuff. So I know that this is also 3. I know this is 5, right? 5, 1, 3, 5, 3. Right? This height's going to be the same as this height. And this length is going to be the same as this length. I've just made a little rectangle. Here, I can find the, let me put this 5 on the outside. I can find this length right here with the Pythagorean theorem, right? I can do a squared plus, or oops. The two legs are 3 and 1, so 3 squared plus 1 squared equals c squared, c being the hypotenuse of this right triangle. Then I just square root both sides. And I'm going to write this c on the left. C equals, and then that's just something I can put into my calculator. It's going to be the square root of 10, right? Or I'm going to round to 3.2, right? So we have that one. And now we need these two sides as well. Maybe I'm just going to give them names, X and Y, so we can look for them. You can give them whatever names you want. And now we got to use some trig, right? So we have an angle on a side, so we're going to use trig, aka SOHCAHTOA. And here, so we have this angle. Let's say I'm looking for y first. This 3 is opposite, and this y is adjacent. So which one has opposite and adjacent? Tangent does. So tangent of the angle, 30 degrees, equals opposite, which is 3, over adjacent, the side next to the 30 degrees is y. Solve for y. I'm going to do this one kind of fast, right? So y times tangent of 30 after we multiply the y over equals 3. And then tangent of 30 is just a number we can divide by. And so we get y equals 3 divided by the tangent of 30, which luckily we can put into our calculators. And we get 5.2. And now we can do a similar thing for x. All right, now we're working with opposite and hypotenuse. Which one does that? Sine. So we can do, if I can hopefully find the right room here, the sine 30 degrees equals opposite, which is 3, over the hypotenuse, which I labeled x. We're going to multiply the x over, and so we get x times the sine of 30 equals 3, divide by the sine of 30 degrees. And we get x equals 6. So I can replace x here with 6, and I can replace y here with 5.2, and now I have everything I need. All right, so the first one, the area, I can do 1/2 times the first base, which is 5 plus 1, which is, or I could do 5.2 plus 5, which is going to be 10.2 plus 1, which is 11.2. So that's this base plus 5, the top base, times the height, which is 3, and that's just from following. That's just from following this, right? Base 1 half base 1 plus base 2. First base is 5.2 plus 5 plus 1, which is 11.25. And just be careful when you're typing that into a calculator, right? Because you have to do that 11.2 plus 5 before you multiply it. And after you multiply that all out, you should get 24.3. Then again, since it's an area, we're going to do units squared. And then lastly, for the perimeter, all we have to go do is add up all the sides on the outside. So I'm just going to go around 6 plus 5 plus 3.2 plus 1 plus 5 plus 5.2. And that should leave me with 25.4.